Hello student, this is our chapter number 2, the growth of computer and software. Now in our first chapter we discuss about the input and output devices of the computer, and in this chapter we are going to discuss about how the computer is evolution and what are the types of software and how the languages and their evolutions occur. Now in 1917 there were many people who laughed at the idea of home computer, means हाउ द कंप्यूटर कैन बी एट होम ऑफ एनी वन, मतलब किसी के घर में कंप्यूटर कैसे आ सकता है. वाई? क्योंकि उस वक्त जो कंप्यूटर की साइज़ थी वो बहुत ही बड़ी, मतलब रूम की जितनी थी. दे वेर इन द साइज ऑफ रूम एंड दे वेर ऑल्सो मोर एक्सपेंसिव, सो अ common people cannot afford that computer. But the growth of computer and computer industry, okay, and revolution was occur, and this phenomena was true. Now in this chapter, okay, we are going to discuss how the evolution of the computer occurs. Now during the last 50 years, computers have become some perfect example of modern convenience. Now this is also magical computing devices, but in the starting of discovery it was not as same as today. Okay, this is the knowledge byte and also some important invention. In 1939 there was a calculator developed, then 1944 first computer came, 1947 keyboard, then 1950 the idea of digital computer came, in 1960 there is mouse, and 1972 the first video came, okay, game came. Then 1975 portable computer, means a small computer. 1996 computer in USA. Then 1901 World Wide Web. 1998 a Google. In 2004 Facebook idea was came to the people. Now generation 0 or mechanical calculating machine. Prior to 1500 a typical European business person used abacus for the calculation and record the result in Roman numbers. After the decimal system, this Roman numbers is finally replaced. A number of people invented a devices to make a decimal calculation even fast and more accurate. Blaise Pascal, who developed a mechanical calculator also known as Pascal line calculator to help his father with his tax work. Now this calculator can do addition with carry and subtraction, and this was the probably first mechanical device which actually used for the practical purpose. Next one is Gottfried Wilhelm von Leibniz, who is a noted mathematician and invent a calculator which is known as step reckoner that could add, subtract, multiply and divide, and none of this device has program or had a memory, so they require a manual invention through each step of their calculation. Next one is Charles Babbage, who is also known as a father of computer, and he built his different engine, and he got this name because he used it to calculating a technique which use a method of differences. This machine was designed to mechanize a solution of polynomial functions and was actually calculator. Okay, the first machine or difference engine was a calculator, not a computer. But after invention or after evolution in the different engine, the computer idea came. Babbage also designed a general purpose machine which is called an analytic engine, and it was designed to be more versatile. Versatile means doing a different thing than his earlier difference engine. Now the first generation vacuum tube computer. Now first generation, okay, that is relied on the machine language and also known as low level programming language, which is only understood by the computer, and they could only solve one problem at a time, and they used a vacuum tube, and also they were taking a more size, taking up the entire room, and also more expensive to operate, and in addition they requires more electricity, generate a lot of heat, and due to this sometimes they go of the malfunction. So here some knowledge by Charles Babbage, who is known as the father of computer, and his machine were mechanical, not electrical or electronic. Means they requires a mechanic power, not electricity. Okay. The most important late 19th century, the tabulating machine. It was developed by the Hermann Hollerith, and his was machine used for the encoding and compiling 1890 census data. And Hollerith later founded the company and went on to become the IBM. The UNIVAC. It was the first commercial computer which is delivered to business client. The US Census Bureau in 1951. The Athens of Berry computer. It was the binary machine and built from the vacuum tube. The ABC had some features in the common with the general purpose ENIAC, electronic numerical integrator and computer, and it was invented a few years later. Now ENIAC is recognized as the first all electronic general purpose digital computer. This machine used 17,468 vacuum tube and occupied 1,800 square feet of floor space, weighted of 30 ton and consumed 174 kilowatts of power, and it had a memory capacity of about 1000 information bits and use a punch card to store the data. Here the example or figure of vacuum tube is given, which is made up from the glass. Now ENIAC had shown that vacuum tube computer were fast and feasible. During the next decade, vacuum tube system continued to improve and were commercially successful, and this ENIAC and UNIVAC are the example of first generation of computer. And the second generation, which is of 1956 to 1963, and it was based on the transistor technology. Vacuum tube were replaced by the transistor in second generation. Okay, in fact, ENIAC detractor believe that system will never run because of tube will burn out faster than they can be replaced because of heavy electricity, heavy heat generation. Vacuum tubes are sometimes breakable, okay, because they are not a heat tolerable. So system reliability wasn't as bad as they had predicted. Vacuum tube system often experience more downtime and than uptime. So 1948, three researchers with the Bell Laboratory, John Bardeen, Walter House, Britain, and Bradford, they invent transistor. This new technology revolution make a huge revolution, okay, in the televisions and radios, but also pushed the computer industry into new generation. And because of this transistor, the transistor consume less power as compared to vacuum tube, and also small, so it also reduce the size of computer, okay, and also give the reliability to the computer. Now using this transistor, this generation was still bulky and quite costly, typically used only in university, government and large business website. Okay. Nevertheless, a plethora of computer makers emerged in this generation. IBM, then Digital Equipment Corporation, UNIVAC, okay, they dominated the industry. Third generation. Second generation, this is well suited for either scientific or non-scientific application, but not both. So thus in 1964, IBM announced a System 360 family of mainframe, where each processor had a set of large built-in instructions. Some of these instructions could be used effectively for scientific calculation, while the other were more suited for record-keeping application. The computer in the generation used the technology of integrated circuit, okay, also sometimes called IC, and this is made up from the semiconductor material. Since this IC were small in the size, so also it reduced the size of this computer, and this is the real explosion in the computer use came with the integrated IC generation. Fourth generation, okay, 1971 to present, VLSI computer, a very large scale integration technology. In the third generation, electronic revolution, multiple transistors were integrated into one chip. As the technology advanced, the size of IC reduced, more and more components could be packed into a smaller chip. So they were called large scale integration LSI technology and very large scale integration VLSI technology. There are more than 10,000 components per chip in the VLSI. This last level, VLSI, marks the beginning of the fourth generation of the computer. VLSI allowed Intel to create the world's first microprocessor, the 4004, which was fully functional 4-bit system. This allowed computer of the fourth generation to become smaller and faster as compared to earlier generation. Fifth generation, it has been next is fifth generation. It had been predicted by that earlier 21st century the computer should be able to behave like a human being. So they would be able to think and act on their own. So this situation is very well depicted in the motion picture Terminator 2. Okay, it is also the best example that how robots take their own judgment. Languages and their evolution. Now, programming language. So what is language? Why and why we use the language? We use the language for the communication purpose, and to communicate with the computer we need a programming languages. Programming language were used even before the computer invented. For example, a player piano scroll, a long roll of encoded paper tape, okay, they are the considered as earlier form of programming languages because it contain instruction. They need to make piano a play tune. So the first generation language is also converted into five generation. Now first generation language, they are also known as machine languages, and the first generation programming instruction were entered through the front panel switches of the computer system. Machine language is also known as binary language, which consists of ones and zeros. Second generation programming language, it is associated with assembly language, okay, and they can be written with help of symbolic English word, they known as mnemonics, in way what that human can understand and subsequently converted into machine language by the assembler. Assembly languages are specific to computer and CPU, and the term used in the distinction between machine language, which is first level language, and higher programming language, which is of the third, fourth and next generation, is also known as a second generation language. Third generation programming language. This language is grouping of programming language that introduce a significant enhancement to second generation, and they are more friendly. Fourth generation language, they are the grouping of programming language and get closer than third generation to human language. It means in the form of English language, form of thinking and conceptuations. They are designed to reduce the overall time, effort and cost of software development. Now example are structured query language, SQL, then Informix 4GL and Cold Fusion. Fifth generation programming language, they are the grouping of language and built on the premise that problem can be solved. Application built to solve it by providing constraint to the program rather than specifying algorithm how the program needs to solve, and this type of language are often used in the artificial intelligence. Next is compiler and interpreter. Now this type of high compiling or high level languages, they needs to convert into machine level language. so the computer can easily understand it. The high-level program is known as a source program and the corresponding machine-level program is known as object program. So, compiler and interpreter perform the same task, but there is a difference in their working. An interpreter is smaller than compiler. Compiler. It is a process that translate high-level program into one language or into equivalent program into another language. Now that language is object code or target language. The program that reads in as an input a program, okay, that is of the high-level programming language, and it is similar to English and needs to output into a machine language code, okay, which is in the form of binary 1010. Now interpreter, they reads program as a source program along with the data and program, and it translates the source program instruction by instruction. For example, Java interpreter, they translate a class file into code that can be executed, okay, natively on any underlying machine. And the second example, program virtual PC, that interprets program written for the Intel Pentium architecture for the power architecture. This enables Macintosh user to run Windows program on their computer. Now what are the functions of interpreter? So interpreter checks the error of a program, okay, statement by statement or instruction by instruction. After checking one instruction, it converts that statement into machine code and execute that statement. The process continues until the last statement of program occurs. It closely related to compiler but take a both source program as well as input data. It translates some form of source code into target representation that it can immediately execute and evaluate, similar to that of compiler, but amount of time it takes to produce executable representation will vary as will the amount of optimization. Now the following diagram. Compilation. Okay, so compilation, okay, they take a source code and convert into executable code. Okay, this is what come into pre-processing phase, and this executable code is converted into machine code. And the next one is source code. Okay, they convert into a intermediate code, okay, which is done by the compiler, and then interpreter will interpret this code, okay, and execute this file. The important key point is to note that with simple assembler there is one-to-one correspondence between mnemonic code and the machine code that the assembler generated. So in assembly language we are going to use a symbol or any mnemonic, okay, they represent some numeric code and that makes the computer to operate. This was a huge advance in the productivity, but not as much in terms of the theory of sophistication. Now here is example of assembly language. Here add, BRA branch, then CMP compare, then move, then pop up the value, return, then shift right. Okay, this is what the mnemonic, and this mnemonic have some machine code which is of binary 101010. So this is convert mnemonic to a machine code. Now do and learn exercise. The first generation computer was rely into a machine language. Then ENIAC and ENIAC, they are the example of first generation. Now transistor replace a vacuum tube. In the second generation, transistor are in the second generation. High level programming languages were being developed in the third generation. And master control of program that runs the computer, so that is a operating system. Okay, fifth is operating system. Now true false, okay, ये एक बाकी रह गया है, इसमें आएगा फिफ्थ में ऑपरेटिंग सिस्टम. Write a true false. Now second generation of computer is still in under development, so true, okay, second के बाद third, third के बाद fourth, fourth के बाद fifth. Okay. First generation computer is associated with artificial intelligence. No, first is not. It is a fifth generation. COBOL and Fortran are the version of second generation. False. COBOL and Fortran are the version of the third language or third generation. In second generation, programs were written into assembly language. Thus, true. Now in the third generation, LSI and VLSI were invented. No, it was in the fourth generation. In third generation, there is integrated IC. Now compiler, so they program that translate a source program into high-level programming language. Interpreter, so read executable source program written in a high-level programming language. Third generation, so integrated IC. Second generation computer, so vacuum tube cut करके transistor. Okay, I have write there transistor because vacuum tube is in the first generation. So either you have to change a first generation, okay, option 4 to the first generation, or either change the option C to the transistor. Machine language. So this was of the first generation. Answer the following. Do you think that software and hardware are independent on each other? No. Okay. इधर यहाँ पे यस की जगह पे आपको नो करना है. नो. To run a software, we need a hardware. And without software, there is no use of hardware. So this option is no. Okay. What is machine language? It is low level language which is made up of the zeros and 1. Okay, please reminder guys, you have to change yes to no in the first question. Okay, remember please. What are the advantage of the third generation language over the first and second generation? So they were small in the size and fast execution. Discuss the evolution of programming language. This language were used even before the computer is not invented and evolved from the machine to third generation. Okay, and which is related to human language, or we can say that it is related with the English language. Now what is the difference between compiler and interpreter? So compiler translate source code to a machine code, and interpreter they execute the source code. Fill in the blank. Java is example of third generation. Operating system are system software. Compiler translate program written in high level language to a machine language. Series of instructions that is given to a computer to perform a task is known as program. The only language understood by compiler is machine language. So this is what your chapter number 2. Now you have to write this exercise in your textbook with pencil only. Okay, and just remember here you have to change no. To run a software we need hardware and software. Okay, and without software there is no use of hardware.